Okay, so we start off the course obviously with algebra, methods in algebra, and we start off with a very basic idea that we would have learned. Like terms can be added or subtracted, unlike terms cannot. Because if I've got something, I don't know what it is, but then I've got two of them, I can add them, I just still don't know what the answer is, but I know I've got two of them. So, you know, x plus x is 2x and so on. And that's the basic idea. But if I've got x and I've got a y, so they're both unknown, but they're different unknowns, I can't add them because I don't know what either of them are. So, basic idea behind algebra. I did bother with any examples on that because I figure we should be okay on that. The next important thing we probably see with algebra are the index laws. And you'll remember that when we multiply, we add the powers. When we divide, we subtract the powers. Parentheses, that's where we multiply the powers. Anything to the power of 0, which is of course a lie, is equal to 1. I say it's a lie. Why is it a lie? Right? There are conjectures and there are theorems. Everything in maths, when we come up with an idea, is what we call a conjecture. It's not a theorem unless we can prove it to be true. Now, a to the power of 0 is equal to 1. Proving things true can be difficult. Some things spend hundreds of years trying to prove things are true. Proving something's not true is easy because all you've got to do is come up with one case where it doesn't work. Bang, it's not true. So I'm telling you, a to the power of 0 is equal to 1 is not true. It's not a theorem, it's a conjecture. Give me an example where it doesn't work. Thank you. 0 to the power of 0. Is that equal to 1? Yet we have another rule that says 0 to the power of anything is 0. Doesn't that contradict? So 0 to the power of 0 is not equal to 1. 0 is just one of these funny numbers. The idea of a 0 was invented out of convenience. For place value, it's very useful. But it does create some problems in maths. So when we say anything to the power of 0 is equal to 1, we're basically talking other than 0. I mean, a negative number to the power of 0 is still equal to 1. But it doesn't really cause us that many problems because it's very rare we come up with 0 to the power of 0 anyway. But what does an index mean? As we go through this sort of thing in maths, we stretch the truth a little bit when we introduce things, and then we develop the idea to a more formal thing. And the first idea of an index, we said, it's how many times you multiply something by itself. And so x cubed meant x times x times x. And that was a really convenient way of doing it, until then we introduced negative indices, and all of that then loses meaning. Oh yes, I'm going to multiply it by itself negative 2 times. What? And then of course we introduced fractional powers as well. I'm going to multiply it by itself a half times. So what do indices actually mean? The way I think about it is positive means I'm on the top of the fraction. That's a little instruction. I'm on the top of the fraction. Negative means I'm on the bottom of the fraction. Or more correctly is put me on the other side of the fraction. So if you have something on the top of the fraction to a negative power, then it should go to the bottom of the fraction. But if it's on the bottom of the fraction with a negative power, it should go to the top of the fraction. So normally when we're just putting it into fractions, negative would go, I'm on the bottom of the fraction. Fractional powers. The way I look at it, the top of that fraction tells me the actual power. And that makes sense, because if I just had x cubed, going back to that example, I could think of 3 as 3 over 1. So the top of the fraction is telling me the power of 3. The bottom of the fraction is telling me the root. Now, the first root of a number is not something we talk about, because it is just itself. Same as anything to the power of 1 is itself. Well, the first root of anything is itself. So we don't normally think of it as 3 over 1, but the bottom there is saying, oh, well, it's the first root, so it is itself. But if it was over 2, then it'd be the second root over 3, and so on. And so that's what they actually mean. So this would be the bth root of x to the power of a, or, of course, you could write it as the bth root of x all to the power of a. The actual order that you do the power and the rooting in doesn't matter. If I'm dealing with a number, I'm probably going to do the root first, because that'll make the number smaller, and then that's easier to raise to the power, rather than going the power first, getting a really big number, and then trying to find the root of that. With algebra, I'll tend to do it that way, where I'll go the bth root of x to the power of a. So x to the negative 3, now I look at that, I say, oh, okay, negative 3, it's on the bottom of the fraction. So 1 on x cubed. I've performed the instruction, so the negative sign's not there anymore. A5b to the minus 7, now I've got to decide, oh look, I've got a positive power, that's on the top, negative power, that's on the bottom. So I could have a whole heap of things. We like doing that in maths, we make things look harder. But they're all just the same instructions. You follow the instructions and you get the answer. The first thing I do is draw in there, it is, the fraction bar, and then decide what's on top. 3/4, easy, they've already done it for me. 3's on the top, 4's on the bottom. So x to the 4 goes down, a to the 9 goes up, b squared goes down. X to the power of quarter, 4th root of x. 2/3, oh well, cube root of y squared. Other way around, 3 on 2, oh, that's the square root of x cubed. But of course in maths, we always simplify our surds, and the square root of x cubed can be simplified. Okay? Because I could rewrite x cubed as x squared times x. And the square root of a perfect square is itself. So that becomes x root x. Simplify the surd. Now, how do you spot that? It's when you've got an improper fraction that's going to happen. Okay? So x to the 3 on 2, whilst I see 3 on 2, I think 1.5. I never write that down. That's just what I'm thinking. 1.5. And that tells me then how to simplify the surd. It's x to the power of 1 and x to the power of 1/2. And of course we multiply because we talk about indices. So we get x root x. Simple. So x to the power of 1 and x to the power of 1/2. So something like this, which of course we're probably never going to see, but we can still use the same idea. 27 on 4 is an improper fraction. If I made it a mixed numeral, that would become 6 3/4. So it's going to be m to the power of 6 times m to the power of 3/4. So m to the power of 6 times the 4th root of m cubed. Bang, there's the answer. So if I had something like this, again, we're just trying to make it look harder. It's still all the same idea. First thing is I draw in, and what is that called? Oh, I'm glad someone has taught you maths. Very good. Often I ask that question and people just look at me blankly. We lose the language of the maths. Yes, that's called a vinculum. Those who thought it was just called fraction bar, well, I suppose it is, but the technical mathematical name is vinculum. All right, so 1/2 is already decided for me. 1 goes on top, 2 goes on bottom, but as you know with algebra, if I'm going to put some pronumerals down, we don't worry about writing the 1. -6, so that's on the bottom. Positive 500's on the top. Oh, minus 1 on 28, so it's on the bottom. 1 on 28, oh, that's the 28th root of q. C to the 7, oh, it's positive, it's on the top. 7 on 6, oh, that's an improper fraction. 7 on 6 is 1 and 1/6, so that would be c to the power of 1 times c to the power of 6, which is the 6th root of c. So we have c times the 6th root of c, and we just top it off with r to the power of 69. There we go. All sorted out nicely. Okay? Just be careful when you're writing your roots. You notice how, and that's just the font I've used here, I suppose, that could be confused c to the power of 6. So we try and get the number, 28's probably written a bit better, we try and get the number in the actual v of the square root sign, although it's not a square root sign because it's not a square root. It actually has another name as well, so I don't have to say square root sign. What is that symbol?
Radical.
Pardon?
Is it a radical?
It's very radical. Yes, it is. It's a radical. So that symbol is called the radical symbol. And we make the number a little bit smaller and we put it in there to make it clear. 2/3 to the power of -2. If I see a fraction to the negative power, the quickest way of doing it is to turn the fraction upside down, make it a positive power. because remember, it's really just saying 1 over. And when you have 1 over a fraction, you invert and multiply. So rather than doing all those steps, if I see a fraction to a power, just invert it, change it to a positive power. 3 on 2 squared gives me 9 on 4. Okay, there's our first bit of theory. Was that fun or what?